Hey guys, so I got a request from a student to give a little bit more of an in-depth video for factoring polynomials. I can't really say a whole lot more than what I've already said in my previous video, but I want to walk through at least a couple of these problems that are on your assignment. And while I go through these, I encourage you to pause the video after I do a step or two and then try to keep going with the problem on your own. So just watching me do this all myself is not going to help you. You've got to struggle through it a little bit in order to really understand the material. And that's okay. That's normal. Struggling through this is definitely normal. As I said, this is one of the tougher topics for a lot of students, and also, like I keep saying, it will show up a whole lot in geometry and especially algebra 2. So don't worry if you're struggling through it right now. Just keep trying. We'll get you there. Keep trying, and then we'll practice it a lot in geometry, and then you'll have to apply it a lot in algebra 2. All right. So I'm going to go through a couple of problems down here. Um, and again, this is the second part. So there's only 10 questions on this second assignment. The first assignment was two pages. It was double-sided. This is just the 10 problems. So I'll go through two of them with you. You guys had to do the other eight. If you've already submitted your assignment, remember you can unsubmit it and then you could make some changes and submit it again if you'd like to do that. All right, so what I wrote right here is two steps. Anytime you factor, you always want to look for these two things. The first step is factor out the greatest common factor if one exists. So on any one of these problems, if you see a greatest common factor, and I see it on a lot of these, I mean, just looking at these numbers really quickly, I see that a lot of these numbers are divisible by 2, like on 3, 8, 4, and 9. All of the terms are at least divisible by 2. Just double checking here. Yep. So all of them are evens. So I know at least a 2 could be factored out immediately, and there's probably something greater than that. Not on number 4 here because this says just a 2, but there's probably something greater than that on these other 3 that you could factor out. So factor out the greatest common factor. That's the first thing you want to look for. And the second thing is then factor the remaining trinomial. And if there is no greatest common factor, then you just go right to factoring the trinomial. All right, so let's go through, let's start with problem number 3. So on number 3, again, we're looking for a greatest common factor, anything that is that all three terms are divisible by. So like I said, they're all even, so they're at least divisible by 2. So let's say you're sure it's a 2, maybe it is, maybe it isn't, but let's say you're like, yep, it's 2. Okay, so let's take out a 2. And remember, when I say factor out the greatest common factor, it's just reverse distributing. You're dividing out the 2. So if I were to multiply in or distribute in the 2, I should get back to where I started with that original trinomial. So 2 times something has to give me that first term. 2 times what gives me that first term? And again, I encourage you to pause it right now and try to fill in this trinomial in these parentheses on your own. All right, so 2 times what gives me 12n squared? 2 times 6n squared is 12n squared. 2 times what gives me negative 26n, and that's going to be a negative 13n. And then 2 times what gives me negative 16, and that's going to be negative 8. 2 times negative 8. So again, you could distribute the 2 back into these parentheses, multiplying in the 2 on all three of those terms, and you get back to where you started, and that's how you know that you're doing this correctly so far. All right, so I said maybe it's a 2, but maybe it's not. Well, if you think, yep, it's definitely a 2, I'm going to take out a 2. Okay, but now look at this trinomial. If there was still a greatest common factor within this trinomial, you would have to factor that out again. So in this one, let's say, just for argument's sake, let's say this wasn't a 13 in the middle. Let's say this was a 12. Well, then I could go, oh, shoot, I didn't factor out the greatest common factor. I can still take out another 2, and then it'd become a 2 times 2 out in front here, and it'd turn into a 4. But in this case, none of these have a greatest common factor because 13 is a prime, and 6 and 8 are not divisible by 13. To be divisible by, it means it has to divide by the number and give you a whole number as a result. So like 12 is divisible by 2 because 12 divided by 2 is 6. 6 is a whole number. Okay, I should say an integer because it includes the negatives. All right, so step 1 is complete. We factored out the greatest common factor because 1 existed. Step 2 says factor the trinomial. Well, this is the trinomial that I'm talking about. So we just carry down that 2 throughout our problem, and we look at this new trinomial. So we're going to be looking for two binomials that when you multiply them together give you that trinomial. Because again, I said this a lot in my last video, I'll keep saying it. A trinomial is factorable if it can be written as the product of two binomials. So we always want to take a trinomial and break it down into two binomials. And a binomial, again, just means it has two terms. So we have two of these polynomials with two terms, two binomials. So we have to fill in these four positions. That is our goal. That is how we are going to factor the trinomial. We fill in the four different positions of these binomials. And if we were to multiply them back together, remember, to multiply binomials, you FOIL, multiplying the first two together, the outside two together, the inside two, and the last two. If you FOIL them together, you should get that trinomial back. So every step you could work your way back up to get back to the original trinomial. So you could FOIL these together to get back to the previous step. You could distribute in the two to get back to the first trinomial. All right, so this is the hardest part in my opinion. At least for students, this is the hardest part. What has to go in these four spots? So you've got options, and that's really the toughest part for students, is that it's not one set thing that you can just immediately see and get. You have to think about it. So let's try some possibilities. So I need to get a 6n squared when I multiply my first two positions together. So what two values multiply to 6n squared? Well, 6 is not a prime number, so there's multiple options. So we're going to try some of them out, and I'm just going to try them in the middle here. So I'll just break off all of this, break off all of that. All right, so let's try some options. So let's say I'm trying to factor 6n squared minus 13n minus 8. Let's say I try in those first two positions. In these first two positions, I need two things that multiply to 6n squared. So let's say I try 2n and 3n, because 2n times 3n is 6n squared, and that's what I need right here. So that's one possibility. Well, then the other issue is that in these last two positions, I've got to have those multiply together. Again, I'm thinking if I FOIL first, outside, inside, and last, the last two are going to just be two constants, two numbers. And when I multiply those last two together, I need to get this constant, the only term with no other n's in it. I need to get this constant when I multiply those last two together. So the problem is I need to get a negative 8. But there's multiple numbers that multiply to negative 8. So you have to start thinking of some possibilities. So I could try a negative 2 and a positive 4. That's one possibility. So this is just one potential combination of values that could give me this trinomial. You've got to double check this. We've got to FOIL this together and see, do I get that trinomial? So multiply the first two together. We already know that should equal 6n squared. Then the outside two, that gives me an 8n squared. Oh, excuse me, an 8n. I don't have an n over here. So that gives me an 8n. The inside two gives me a negative 6n. And then the last two gives me a negative 8, which I knew that would happen. All right, so we have the 6n squared. We know we're going to have a 6n squared because we picked the values that would give us a 6n squared. We're going to have the minus 8 on the end, and I know I'll have the negative 8 on the end because I picked those two values when I'm going to multiply these last two. I know I'll get that negative 8 because I chose those values to multiply to negative 8. The problem is the inside two terms. Do those combine to give you that negative 13n? So is 8n minus 6n negative 13n? And the answer is no. It gives you a positive 2n. So this combination of values does not give us this trinomial. If this trinomial was this one, 6n squared plus 2n minus 8, then yeah, we'd say we factor that correctly and we could be done with it. But obviously it's not this trinomial. So this is the incorrect combination of values. This did not work. So we need to try another one. And again, the more you do this, the more you're going to start to be able to kind of go through this in your head, and it'll speed up a lot. But for now, it's really just going to be a guess and check process. So just keep trying different combinations. So in the middle here, we got a 2n. We need a negative 13n. So I need to have this turn out to be a negative. I need the larger of these values to be a negative. So let's go with 2n. Let's try, we need two numbers that multiply to negative 8 in those last two positions. So I'm still going to try 2n and 3n to get that 6n squared. But in the last two positions, I'm going to try a negative 6 and a positive, oh, what am I doing? A negative 8. Sorry, we're supposed to get negative 8 on the end. A negative 8 and a positive 1. Let's see what happens with this combination. So we multiply the first two together, we get 6n squared. The outside 2, we get negative 16n. The inside 2 is a positive 3n. And the last 2 is a negative 8. Alright, so here we're going to get 6n squared minus 13n, when we combine those middle two together, minus 8. And now you can see that this is the same trinomial as what's in the parentheses right here. So this is the correct factored form. These are the values that I have to put right here. 2n plus 1, 2n plus 1, and 3n minus 8. And if you switch those around, let's say you had 3n minus 8 over here and 2n plus 1 over there, that's still correct because that commutative property of multiplication says you can switch the order of what you're multiplying. It doesn't change the result. So if you flip-flop these factors, that's still correct. So I required 2 possibilities and I got it right. Maybe you tried 10 possibilities and on the 10th one you finally get it right. That's okay. As I said, the more you practice this, the faster you're going to start to speed up and kind of see some different patterns for different kinds of problems. But for now, just keep trying different possibilities. So some of you are turning in your assignments and you're just showing me the answer. Now, I know that a lot of students that are just showing me answers on every single problem are not actually trying the problems. You're just using Photomath or some website to factor these for you. I mean, great, you're going to get your points. But next year in an Algebra 2, when you don't have that at your disposal, you're going to really struggle. So please, please, please struggle through these for now. Try out all those possibilities. If you're sitting there trying 10 possibilities, hey, if there's 10 possibilities, try them. Try them until you get the right one. So you might not get it on the first or second try. Keep trying different possibilities. But for my sake, this is the answer. Because again, if I FOIL these together, I get that trinomial. So I mentioned this in my last video too. Please actually circle your answers. I just got a couple more submissions from this assignment, and you're not circling your answers. And some of you are actually multiplying these back together and getting back to this original trinomial. So your last line of work says the original trinomial. I have to make sure that you understand that this is the factored form. I don't want you thinking that you're supposed to multiply these together and then get back to that trinomial and that's your answer, because then all of the problems would be the answers. So the factored form, when it's written as the product, meaning you're multiplying, written as the product of unfactorable factors. So you should have an answer that essentially has things that you cannot take out greatest common factors anymore, and there's no trinomials that we could factor any farther. So please circle your answers. All right, let's try one more. Some of these have pretty big numbers in them, especially number 5. So let's go through number 5 together, and then I'll leave the rest of them up to you. So let me get rid of everything that I've done so far here. Get rid of all this. I know some of you are sitting out there like, erase that. I'll do it. There you go. All right. Okay, so let's go through this last problem, number 5. So again, we're going to look for the same things. Factor out the greatest common factor if one exists. Well, one definitely exists because all of these are even. So I could at least take out a 2. Now these are some pretty big numbers, so I'm going to guess I could probably take out something larger. So all I'm going to do is pull up a calculator here and just see, okay, what is 60 divisible by? Is 60 divisible by, let's say for something a little bit bigger. I know that 10 is not going to go into 88 because it doesn't end in a 0, but let's look for, oh, I don't know, how about, let's try 6. I know 60 is divisible by 6 because you get an integer when you divide it, so let's try, is 88 divisible by 6, and no, it is not. So let's try something else. Is 60 divisible by 12? Yep, okay, so is 88 divisible by 12? And no, it is not. So we have to keep trying different things, and we're trying to find the greatest common factor. Now, if you're sitting there for a while and you're like, I cannot figure out what this thing is divisible by. Okay, it's divisible by 15, but is 88 divisible by 15? No. Okay, is anything going to go into 88? So if you're not sure, what you can do, as I set up here, is just take out the small, not the greatest common factor, take out some common factor. So I know they're divisible by 2 because they're all even. So let's just start by taking out a 2, by factoring out a 2. So what would you have to write in these three spots to get back to that original trinomial if you were to multiply them by 2? So 2 times what gives you 60h squared, and that is 2 times 30h squared. 2 times what gives you negative 88h, and that's negative 44h. And then 2 times what gives you negative 192, and that's a negative, oh, I don't want to get this wrong on video, so I'm just going to pull this guy up, 96. All right. So, do we still have a greatest common factor? Well, this is even, and that's even. So yes, 2 is not the greatest common factor. I still have a common factor between these three terms, but that's okay. I can still factor out another common factor. So let's factor out, how about another 2? I still don't see anything bigger that can go into those three terms, so let's factor out another 2. So I've got my original 2 here. I'm going to factor out another 2, so it's going to turn into 2 times 2. And then what would have to remain here to get that original trinomial if I distribute that 2 back in? So 2 times what gives me this one? Well, 2 times 15h squared. 2 times what gives me the middle term? And that's a negative 22h. And 2 times what gives me a negative 96? And that is a negative 48. Okay, so do we have any common factors still left inside of here? Well, 15 is not even, so I know 2 is not going to go into all three of these values. So what other numbers go into 15? Well, I could try 3, but 3 doesn't go into 22. I could try 5, but that doesn't go into either of those numbers. I could try 15, but 15 does not go into 22 or 48. Those are not divisible by 15 because you would not get a whole number when you divide them by 15. So my greatest common factor was actually a 4. 2 times 2 is 4. So if I would have seen that right away, if I would have seen that 4 is the greatest common factor, I would have saved myself the extra step right here, but that's okay. So if you don't see the greatest common factor right away, you can take out any common factor and just keep taking out common factors until you no longer have any common factors left. So 4 was actually the greatest common factor. So that accomplishes that first step. All right, for the next step, we need to factor the trinomial. So we still have to factor this trinomial. So I carry down my 4. And then again, a trinomial is factorable if it can be written as the product of two binomials. So I'm going to have a binomial here with 2 spots and a binomial here with 2 spots. So this one, there's some bigger numbers than we were dealing with in number 3, but it's the same process. You're still looking for 2 values that are going to multiply in these first 2 positions to 15h squared. You're looking for 2 values that are going to multiply in the last 2 positions to a negative 48. And again, I encourage you to pause this video and try to fill in those positions on your own, and then watch it after the fact and double check that you got it correct. Just watching me do this will not help very much. All right, so what values multiply to give me a 15h squared? Well, I've got some possibilities. I could do 15h and 1h. I could do 3h and 5h. So there's some different possibilities here. I'm looking at this middle term and I'm saying that's a negative 22h. So I need negative 22h's here in the middle. So I'm thinking, okay, I'm going to try, again, I'm just going to try some possibilities. Let's just try some possibilities over here. I'm going to try 3h and 5h. And if I exhaust all the possibilities with 3h and 5h, then I go, well, shoot, I should have tried 15h and 1h. Okay, so I have to keep pausing this myself because my son keeps hitting the walls with a toy hammer. So anyway, let's try to find 2 values now that multiply to negative 48. So what 2 numbers are going to multiply to negative 48? Because again, I'm thinking of foiling this. I'd have to multiply the first 2, the outside 2, the inside 2, and those last 2 are the only 2 that are going to get multiplied together to just give me a number without any h's in it. So I need them to multiply to negative 48. So I'm thinking, again, we've got possibilities here. I'm going to try 6 and 8 first. If that doesn't work, I've got to keep trying more combinations. So I'm going to try 6 and 8. So I'm going to go, I need negatives and a negative here. So they have to multiply to be a negative 48. And they have to, again, I'm thinking of patterns. I'm seeing a negative here. So the bigger number is going to have to be a negative. So I'm going to go, when I FOIL them together and start combining them, I'll have to get a negative. Let's go with a negative, I'm going to go negative 8 here and a positive 6 here. And again, this is probably incorrect, but we're going to try it out. So let's see. If I multiply the first two, I know I get 15h squared. 15h squared. If I multiply the outside two, I'm going to get an 18h. The inside two, I'm going to get a negative 40h. And the last two, I know I should get that negative 48. So let's combine those middle two terms together and see what we get. So I have 15h squared. 18h minus 40h is going to be a negative 22h. And look at that. On the first try, I got the correct values. And on this one, I'll be honest with you, I kind of, I'm not going to say cheated, but I thought ahead. I was multiplying different combinations in my head as I was doing this. Um, I was able to figure this out ahead of time. So if you have to try, like I said, if you have to try 10 possibilities, that's okay. The more you try these, the faster you're going to be able to get to this. I mean, even personally myself, I might have to try a few combinations before I get this, but the more you practice them, the easier it'll be to start doing this work in your head, and you'll be able to get the answer a lot faster. So over here, I need to write 3h minus 8 and 5h plus 6. And there we go. So none of these have any greatest common factors in them. So I know that I factored this correctly. This is my answer. So just to recap, again, the first thing you want to do is look for the greatest common factors. If there's a problem that doesn't have a greatest common factor, then you go right to the second step. But both of the problems that I just went through have a greatest common factor. So on number 3, I took out a 2. On number 5, I tried to take out a 2, but ended up with another common factor. So I took out another 2, which multiplies to a 4, and that was my greatest common factor because there was nothing else that these three values are divisible by. After you do that, you're looking at the trinomial, and that's where it says factor the trinomial for the second step. You look at the trinomial and you try to factor it. So again, a binomial is factorable if you can write it as the product of two, I think I just said binomial. A trinomial is factorable if you can write it as a product of two binomials. So on every single one of these, you're going to have a trinomial. You're going to factor it into the product of two binomials, and that's where you just start the guess and check method. So you're trying to figure out values that you would have to plug in these 4 spots. And again, these first two, think of FOIL, the first two have to multiply together to give you the first term. So on this one, they had to multiply together to give me a 6n squared. On this one, these two values in the first two spots had to multiply together to give me that 15h squared. Okay, then we need the last two values to multiply together to give you the last term. So on this problem, these two, negative 8 and 6, had to multiply together to give me that negative 48. And on this problem, the 1 and negative 8 had to multiply together to be a negative 8. And that's just thinking of FOIL. The first, outside, inside, and last. So the first and the last are the two I'm showing here. The first two multiply to the first term. The last two multiply to the last term. The other two parts of FOIL, outside and inside, those two parts are how you end up getting this middle term. So when I FOIL these together, first, outside, inside, last, the first two gave me the first term, the last two give me the last term. The outside and inside, that's how I'm getting these two middle terms here, the 18h and the negative 40h. And those are what have to combine to be that negative 22h. That's really the tough part of factoring. Finding the numbers that give you the two middle values that combine to this middle term. But after you end up writing some possibilities, foiling it out to double check, and getting that original trinomial that you had in your work here, then you know that this is the factored form and you can include that in your answer. So that's really the process on these. So you have 8 other problems you have to do on your own. Hopefully this helped a little bit. If you have more questions, please let me know. I understand that this is not the easiest thing in the world because there's a lot of possibilities that will not work, but please, please, please just keep trying. We'll review this a lot in geometry next year, and then you're going to apply it a lot in Algebra 2 the following year.